Hello, I'm Mr. Bob, and welcome to my Algebra 1 video series. This video covers Chapter 7, Section 2, titled Solving Systems Using Substitution. By the end of this video, you will have reviewed methods for solving systems of equation using substitution. You will review system solutions by simply using substitution and then using the distributive property. You'll also get a look at a real-world problem. Please subscribe to this channel if you find this video to be helpful. Thank you. Okay, before we get started, I'd like to go over one definition here. It says substitution method. What is the substitution method? A method for solving systems of equations is the substitution method. By replacing one variable with an equivalent expression containing the other variable, you can create a one-variable equation, and then you can solve using the methods shown in Chapter 2. Okay, in Objective 1, using substitution, we'll go over that slide again, that info. It says you can solve a system of equations by graphing when the solution contains integers or when you have a graphing calculator. If they're not integers, they're hard to find out exactly where the lines cross. What you're trying to do, remember, is look at exactly where the two lines cross each other, and then that's your solution. But if they aren't integers, it's hard to find those at times. So by replacing one variable in an equivalent expression containing the other variables, you can create a one-variable equation that you can solve by using methods shown in Chapter 2. So please go look at Chapter 2. It'll help refresh your memory. Okay, example 1, using substitution. Let's take a look at it. Solve using substitution. So they give us two equations here. They give us this, the y equals minus 4x plus 8 and y equals x plus 7. So we're going to solve these two equations like we did with graphing, but now we're going to do it mathematically, in essence, is what we're talking about doing here, right? So step 1, write an equation containing only one variable and then solve it. So it's already that way. You don't have to even write anything. It's kind of simple in this example because right here, y equals x plus 7. You already have this y is solved in one variable. So we can now substitute x plus 7 where we find y in the other equation. So we're going to go down here to our, right here, y equals negative 4x plus 8, and we're going to substitute right here x plus 7. Okay, that's the x plus 7 from right up here, right? We're going to put that now where the y is. Here's the y, and we're going to substitute that with x plus 7. Now this entire equation here is in one variable of x. We're going to solve for x. Okay, so when we do that, we're going to take this, the parentheses will disappear, and we're going to subtract 7 from both sides, and we're going to, however you want to move it around, we're going to add 4 to both sides. We'll end up with 5x. When the minus 4 gets moved to the left-hand side, it's a positive 4. Plus 1 is 5x. And the 7 is going to be subtracted from both sides. So now you have 8 minus 7 is 1, right? So here's 8. Here's the equation. Now we've substituted, and we did the add 4x to each side. We subtracted the 7, and you see we now have 5x equals 1. So we can now divide both sides by 5 to get the x by itself. And when you do that, you have x equal to 1/5. So now we have x is equal to, well, I can also write it as what? 0.2. 0.2 is 1/5. And that's how we'll do it as we move forward. So then the next step in solving this is you solve for the other variable. So you go back to either equation. It does not matter which equation you pick. And you substitute in your 0.2 in for your x in the easiest equation you have. And the easiest one is the same one we used where we had the x plus 7. And we're going to get y is equal to 0.2 plus 7. So now the answer for y is equal to 7.2. So we have 0.2 is the x variable, 0.2 is equal to x, and 7.2 is our y variable. This is our ordered pair, the x and the y value, right? Here's the comma right there. There's the comma. So that's our ordered pair. So once you have that, you can now check it. Go back to and put in both terms. You can put in now, over here you can say 7.2 y, they're going to use this equation here. we're going to say y is equal to 7.2. And we're saying, is it equal to minus 4 times the x value, 0.02, which is 0.8, negative 0.8, plus 8. And negative 0.8 plus 8, here, negative 0.8 plus 8 is 7.2. And yes, 7.2 equals 7.2. Okay, example 1, check your understanding. If you've been with me before on my videos, you know that I'd like you to pause your video on these check your understanding slides and try it on your own. I'll wait for you, and then when you come back, we'll do it together. Okay, the method you use exactly to get your answer and compared to mine might not be exactly the same, but hopefully we'll get the same answer, okay? Okay, I'll wait for you. Okay, now I'm going to assume you've done that and you're back, and we're going to go ahead and try it. Well, the first thing we see, it says solve by substitution. Well, we already have a very good equation right here to use for substitution because it says y is equal to 2x. You have to go no farther. We're going to substitute y for 2x for y. And so we'll go to the second equation, and we're going to say 7x minus 2y, 2x rather, sorry, 2x. Okay, because I substituted the y for 2x is equal to 15. Okay, so now what do I have over here? I have a 7x minus 2x equals 15. So 7x minus 2x is equal to 5x is equal to 15. Now I have to divide both sides by 5 to get the x by itself. Okay, that equals, going over here, by 5, right? Divide by 5. So we get x equals 3. So now that we have x equals 3, we need to substitute back for x to get the x equal 3 to get the y value. So we can go right back to the same one. We can now say that 2 times 3 is how much? Is 6. So I'm going to go back to the same equation. I'm going to say y is equal to 2 times 3. And I'm going to get y is equal to 6. So here's our x value and our y value. So I'm going to draw them. So it's 3, comma 6. That's the ordered pair. Okay, so now check it. So let's go back into the 7x minus y is equal to 15. That's the equation we're going to substitute back. So we're going to put the 3 for our x. So we're going to have 7 times 3 minus 6 is equal to 15. Is it? You can see already that it is, right? 21 minus 6 is equal to 15. Is that true? Yes. So this is a correct solution. X right here is 3 and y is 6. Very good. Okay, example 2, using substitution and the distributive property. So solve using the substitution method. So here we go. The two equations are right here. They're 3y plus 2x equal 4 and minus 6x plus y is equal to negative 7. So what are we going to do? We're going to, first of all, it says solve the second equation for y because it's the coefficient of 1. So when you look through your equations here, you find out, right here, you find out that one of them is simpler than the other. The y is a coefficient of 1, so that's a good to start with, because then you can just move the 6x, and you've already done all the math you need to do. So here we're starting with this, negative 6x plus 1y is equal to negative 7, and we're just going to move the negative 6 by adding 6x to both sides, and you get y is equal to 6x plus 7. So now we have our y term. Okay, so now write an equation containing only one variable. Well, how about 3y plus, right here, 3y plus 2x equals 4. That's one of the equations. And now we can substitute for the y. We have a y value, 6x minus 7. So here it is. We've substituted 6x minus 7 for the y value, y term right there. So now it's 3 times 6x minus 7 plus 2x equals 4. Take care of the distributive property here so we get 3 times 6 is 18x. 3 times 6x is 18x. 3 times negative 7 is negative 21 right there. And then we have the plus 2x equals 4. So now we're going to combine the x's. We're going to get 20x is equal to moving the 21 to the opposite side by adding 21. We're going to get 4 plus 21. So 20x is equal to 25. That means x is equal to 1.25 because it ends up being 25 over 20. Okay. And then that ends up being 1 over, 5 over 4, and 5 over 4 is equal to 1/25, 1.25. So now you have the x value, and, okay, so now we're going to solve the other equation by substituting. So now we have negative 6 times x, which is 1.25, right here. We chose this equation right here. So we have negative 6, substitute the x value of 1.25 plus y equals minus 7. So here I have negative 7.5 plus y, okay, is equal to negative 7. So we're gonna move the negative 7.5 to the other side. In other words, we're going to add a negative 7.5 to each side of the equation, and you're going to get y is equal to 7.5 minus 7, which is 0.5. So y is 0.5. So if we go, since x is equal to 1.25 and y is equal to 0.5, we have the solution to our equations. Okay, so there's pretty much how you're going to do that. The biggest thing here is they're showing you that when you substitute in, sometimes you're going to end up with the distributive property because you had a coefficient of the variable you're substituting for. Okay? Okay, example 2, check your understanding. Solve by using substitution and check your solution. This is your turn to pause the video and try it. There's your 2 equations. We do it and see what you come up with. Okay, I'll wait for you. Okay, I'm assuming that you're back. So let's go ahead and let's do it. Okay, so we're going to have to figure out, well, what do we want to work with as our first equation? Step 1, right? We're going to look for the easiest equation. And the easiest one is the one with the negative y term. And we're going to solve that for y. So when you do that, we're going to start right here with this term right here. Okay. And all we're going to do is, first of all, we're going to get the 2x on the other side. Or we're going to put the y on the other side and move the 3. So we're going to be moving the y, the negative y, to the left-hand side, and we're going to be moving the 3 to the right-hand side. And when we do that, we're going to get positive y is equal to 2x minus 3, right? Because the negative y becomes a positive y on the other side, and the positive 3 becomes a negative 3 on the right-hand side. So now we have y is equal to 2x minus 3. So now we can go back in and substitute. We have our y value. So now we're going to go, let's solve for x. So we have y, so we can pick any one of these equations. It doesn't matter. It would probably be simpler if we used the same equation. Probably. But let's just go ahead and do it anyways. We'll do this one here. So we have y, so now I'm going to say 6 times 2x minus 3. This is our y term right here, right? Y. Here's the y right there. So now it's 6 times 2x minus 3 plus 8x is equal to 28. Now we're going to take care of the distributive property right here. And so we could do adding and, combining like terms. So now we're going to get 12x minus 18. 3 times 6 is 18, not minus 18, plus 8x equals 28. Okay, now just combine the like terms. So the 8x and the 12x become 20x. And now we have a negative 18 here. We have to move to the other side. So a positive 18 over on the other side. And that's going to be is equal to what? 3846. Okay. So that means if we divide both sides by 20 right now. Divide by 20. We're going to get x is equal to 46 over 20. Oops, over 20. And if you take and divide this out, you're going to come up with 20 into 46 goes how many times? Well, it's going to say 2.3. Okay, 20 times 2.3 is 46. So that's our x value. Okay, now we have to solve and get our y value. So let's go back and put into, it doesn't really matter which equation you pick, but let's pick the 3 equals 2x minus y. So I'm going to say 3, right here up at the top again. 3 equals 2, and now we want to substitute the x times 2.3, because we have that, our x value, okay, and it's minus y. So now we want to solve for y, because we're trying to get our y. And we can do the same thing we did before. We're going to put the y on the left side, y is going to go over on this side, and the 3 is going to go over on this side. And when we do that, we're going to get positive y, because we've added a positive y to both sides. Positive y is equal to 2 times 2.3. And then over here, we're going to have a negative or minus 3. We can do this right now, this multiplication. We're going to get y is equal to what? We're going to get 2 times, so that's 6.6. 4.6 minus 3. And y is going to be equal to 1.6. 4.6 minus 3 is 1.6. So now we have our value. We have x equals 2.3 and y is equal to 1.6. That's our ordered pair for the solution to those two equations. And it says to check. So let's just pick one. I'm going to pick the bottom one, okay? So I'll check. I'm going to say y, which is 1.6, equals, oh, I should have wrote the equation maybe first, right? That I'm going to use the y, oops. And my pencil just went, my pencil's going goofy on me. Get rid of that. Get rid of that right now. And back here. So now I'm going to write the equation first for you. I'm going to use the y, not minus y. Where'd that come from? Y equals, oh, I selected the wrong equation. Sorry. Go back to the gold. I'm going to select the 3. 3 equals 2x minus y. That's this equation. And I'm going to substitute in. So 3 is equal to 2 times 2.3 minus 1.6. So is 3 equal to this? Let's find out. Is 3 equal to, I'm going to put a little question mark up there, right? Is it equal to it? So 2, again, that's 4.6, okay, minus 1.6. And what is 4.6 minus 1.6? It's equal to 3, okay? And that checks, okay? Good job. Okay, example 3, it's a real world problem, right? So let's figure out what it says here. It says, your school committee is planning an after-school trip for 193 people to a competition at another school. There are 8 drivers, so that's important. There's only going to be eight drivers, right? Available, and 2 types of vehicles, school buses and minivans. The school buses seat 51 people each, and the minivans seat 8 people each. How many buses and minivans will be needed? So what do we know? We know that there's 8 drivers and we have vehicles, buses and drivers. So the sum of the buses and the minivans has to equal to the number of drivers. You can't have more vans or buses than you have drivers, so you're limited by your number of drivers. And the other thing is, each vehicle, we know how much each vehicle can carry, and we know what the total number of people is. The total number of people right here is 193. So let's see what we can come up with. We know we want to know how many buses, what they want to know, how many buses and how many minivans are needed. So let's let B, buses, equal to the number of buses. That's the number of buses we need. And let M be the number of minivans we need. Okay? So we have B, buses, and M, minivans. So how many drivers do we have? Well, we have 8 drivers. Right here, 8 drivers. And those 8 drivers are going to be driving the buses plus the minivans. So it's the drivers are the number of buses we're going to have, because each one needs one driver, and the number of minivans we're going to have. So M plus B, the number of M's and B's added together will give you how many drivers you have. In other words, you can't have any more buses and minivans than you have drivers. And the number of people you're going to have is 193 people. And you know that when you distribute them between minivans and buses, the buses can take 51 and the minivans can take 8. So now all the data has been accounted for. Each bus has 51 people. Each minivan has 8 people. The sum of all the minibuses and the buses and minivans is 193 people. The sum of the minivans is 8. Minivans and buses is 8 because you have 8 drivers. So solve using substitution. So what are we going to do? Write an equation containing only one variable. Well, the easiest one to do that with is your driver's variable function, right? Because you can just move one of these to the right-hand side and you've already substituted, or you already have your new equation. So we're going to move the B, the buses, to the other side right here. So we had B plus M is 8. We're going to add B to, subtract B from both sides. And so now we're going to have the number of minivans is equal to 8 minus the number of buses, right? So if you have 8 drivers, 8 vehicles, and you subtract a number of buses you have from that, you're going to be left with the number of minivans you have, right? So now write and solve an equation containing B. So let's go to the other equation. So we have 51, we know that there's 51 students per bus plus 8 students per minivan, and the number of students per minivan is M, right? This is B, this is M. 8 is M times 8, 8 times M, and 8, M, is 8 minus B. Here's our 8 minus B right there, because we substituted the M right here in the equation right there, and that equals 193. So now I have 51B plus 6. Now I'm doing the distributive property here. 64, 8 times 8 is 64. 8 times negative B is negative 8B. And that equals 193 students. And now we're going to combine like terms, and the like terms are 51B minus 8B. 51B minus 8B is 43B. 51 minus 8 is 43. And then you have the 64. You got to move it to the other side because we're going to end up eventually getting the B by itself. So you're going to subtract 64 from each side. And when you do that, right here's the subtracting 64. You're going to get 43B is equal to 193 minus 64. That's 143B is equal to 129. 193 minus 64 is 129. Now you're going to divide both sides by 43. And when you do, you're going to get B is equal to 129 divided by 43. And that conveniently comes out to 3. It almost had to, didn't it? So 3 is the B. So you're going to get 3 buses. When you look at that, 3 buses. And you're going to end up getting, you're going to get what? 5 minivans. But let's see. So now solve for M. So now we're going to take the same equation, this small one here, and substitute our B. Here's B. We found out to be 3. So we're going to say B plus M over here. 3 plus M, the number of minivans, is equal to 8. So M is equal to 5. So what is our solution? Um, it's kind of hard to say. What it could have been x's and y's, but we didn't solve it out that way. I'll just leave it like this. So the solution is the schools need 5 minivans and to transport 3 school buses and 5 minivans to support 193 people. And if you check it, we can go back and say 51 people per bus. There's 3 buses carrying three buses carrying 51 people is equal to 153 and people, and 5 minivans each transporting 8 people. 5 times 8 is 40, and 153, the total number of people is 153 plus 40 is equal to 193. And 193 certainly equals 193. You've accounted for all the people. Okay, so there you have it. Okay, example 3, check your understanding. Directions. A rectangle is 4 times longer than it is wide. The perimeter of the rectangle is 30 centimeters. Find the dimensions of the rectangle. Remember, you're going to be dealing with length and width, right? That's basically what we're looking for. They want to know what the width is and what the length is. So I'm going to pause for you. You're going to pause, I guess, not me, but I am going to wait for you to kind of do that and solve this problem. Okay, assuming you've done that, let's give it a whirl. The first thing we need to do is come up with 2 equations because we need 2 equations to solve this system. Because you have 2 variables, you have a length and a width. We need 2 equations. You need 1 equation for each variable. So what's one real common equation that we have? A very common equation is 2L plus 2W, right, is equal to the perimeter. 2 times the length plus, oh, I wrote a times there. Sorry, that's supposed to be a plus sign, not a time. Plus 2W is equal to perimeter, and the perimeter we already know is 30 centimeters. Okay, so there's one equation. 2L plus 2W is equal to 30. What's another equation we know? Well, the other information they gave us was the rectangle is 4 times longer than it is wide. So that automatically is L. L is 4 times longer than what? So L is 4 times the W, right? So L, right, we have that, is equal to 4W. So now we have an L, we already have a 4W, so we can start substituting. So why don't we take the 4W and substitute it in for L in this equation up here? So now we're going to get 4W is the L, so 2 times 4W plus 2W, all right, is equal to 30. Now we're going to multiply this out. We're going to get 8W plus 2W is equal to 30. Now we're going to combine like terms. We're going to get 8 plus 2 is 10W is equal to 30. So W is equal to 3 because you have 30 divided by 10. So now we have the W. So now we're going to put in and we're going to substitute W in, and it doesn't matter what equation you stuff it in. It truly doesn't matter as long as you've used both of them at one time in the process. So I can stick it in right here if I want. I can say W is 4 times 3 is equal to L. So I could say right here, I could say L is equal to 4W, and I can now say L is equal to 4 times 3. So L is equal to 12. So I have W is equal to 3, and L is equal to 12. And if you substitute that back, you're going to find out, if I substitute a 3 in here, I'm going to get just that. I'm going to substitute, I'm going to get L, 12 is 12, and therefore 12 is equal to 12, right? 12, L is 12, is equal to 4 times 3 is 12. Perfect. Okay.